I bought this power switch for the compressor. I also bought this brand new motor. This motor came very well backed. They protect it very well so it doesn't get damaged during shipping. It looked very similar to the original. The original little bit bigger. The 3.7 horsepower. This one is 3 horsepower. It was shown in the description of this motor that it's direct replacement for the compressor that I have. So hopefully this will not be an issue. If the compressor hesitates to start on the generator, I will make or buy a new pulley, smaller, the one that's go on the motor, and this will increase the torque so the compressor will start easy. Yeah, the pulley fitted perfectly. I am going to put this motor together. In the future, I will rewind it. I rewinded a lot of motors in the past. It was one of the early jobs I had. The starting coil is damaged over here. Stay tuned for that if you're interested in something like this. Another thing I ordered, I didn't receive yet, is the breather for this compressor. When I bought the compressor, this part was hanging little bit on the thread that's go inside. I extracted the thread using a screwdriver and unscrew it, and I disassembled this one. It has this marble that go inside, and it has a top cover, and the thread go at the bottom here. The purpose for this to act as valve, so if there is air pressure built here, it will allow it to come out, but if the compressor try to suck air, it will not allow, the marble will not allow air to go inside. It will only allow clean air to come through the filter, which this is a joke for a filter. I don't believe they did something like this. Once I receive this part, I will take the compressor and assemble it. I have a lot of fittings for air compressors, so I don't need to buy anything else. So as soon as I receive this part, I will take it and install it. This over here, a lead hammer, if you tap on a shaft so it doesn't damage the shaft. Don't use regular hammer because it will deform the end of the armature or the shaft over here, and the pulley will not fit easy. This will be stored on the shelf until I am ready to repair it. It's poor quality control on Husky. If I line up the feet on this platform that I built, this base over here, it's at an angle. It's not straight to the feet. I'm not going to drill it. I'm going to build a frame over here so I could build the dryer to pull the moisture out of the compressed air. And then I will take measurement from here to the frame and center this based on the frame. I finished welding the frame. I set the tank on this platform that I built, and I discovered when they welded this over here, it's off the squareness of the feet by 1 3/4 inches. What I did, I put this angle and I measure 9 inches on both sides. And I marked the feet over here. I'm going to drill them 4 holes. The belt will be over here. The 2 pulleys for the compressor and the motor will be on this side. And this is where I'm going to build the dryer. The kill switch will be right here. And then I will plummet it from here to supply air. And I could pick it with the forks once I finish build everything. I could load it easy in the truck, or I could store it in the shipping container. I'm going to pick the tank, drill the holes, grind all the welds, paint it, and then I come back once I'm ready to install the tank on this frame. I am ready to assemble everything. I'm also going to build a cooler and a dryer, and it's going to be installed between the compressor and before it hits the tank, so the tank receives clean and dry air. I bought all these fittings. I will make a list at the end of this project. If somebody interested in duplicate my work, I bought a little bit extra material. And I also upgrade this compressor. It used to have a smaller pipe between the compressor and the tank. I'm going to use, they call this 1/2 inch compression fitting, but the 3/8 pipe will fit it perfectly. All the pipe that I'm going to use is type L. There is 3 types of pipes available for you as a consumer. Type M, type L, and type K. Type M, they usually use it for water connection inside the house. Type L, a 3/4 for the temperature the compressor will reach. It's capable of handling 450 psi. The bigger the pipe, the less pressure it could handle. I don't want to use 1/2 inch pipe because I'm going to add a lot of 90s, and this will cause a friction and will cause heat. So I want to minimize the restriction. That's why I'm going with the 3/4. Between the compressor and before it hit the cooler, I'm going to use this 3/4 inch pipe, and I will put this check valve before it hit the cooler, and then ultimately the radiator and the tank. So when the regulator reach full pressure, or the tank get full pressure, about 150 psi, the regulator will stop the motor from spinning, and there is a small hose connected from here to the regulator, and this will release the pressure inside this 3/4 inch pipe, 3/8 pipe, and this allows the pump to start easy. This 1/2 inch pipe is going to be at the bottom to be able to drain the water, and it will be connected to this via this 3/8 connector to 1/2 inch, and this T is a 3/4 and 1/2 inch over here. It will make sense to you once I finish with everything, so you get a good idea of what I'm building. I also bought this regulator or switch. When the tank reach the 150 psi, or depend on what setup you have, this one set to 155 psi, it will kill the motor and also release the pressure on the compressor, so the next time or the next cycle the compressor could start easy, and I could connect gauge and relief valve to it, and I also could connect this regulator so I could adjust the pressure that go into my tools or the paint gun, etc., I'm going to have two outlets installed in this tank. One over here, and this will be not regulated. Whatever pressure inside the tank, it will be going to the tools. And then over here, I will install the switch, and then the regulator will be attached to it. And I could use another outlet and it will be regulated. I could regulate the amount of pressure going to the tool. You could use two-way to braze the copper pipe. You could use this, solder and baste. However, for the temperature, this pipe will reach, especially at the beginning or at the coolant section, it's going to be near the temperature this melt. It's maybe okay, however, I have this silver solder and I'm going to use it. It required higher temperature, that's why I'm going to use propane and oxygen or this oxyacetylene torch to braze everything. The way I designed everything, it's going to fit inside this frame, so I could carry it easy with my tractor. I made it like pallet at the bottom, so everything will be contained here. I will build the cooler over here, and then the dryer, I will build it in the back wall. If you are not planning to build something like this, you could build everything on the wall next to the compressor. Use same principle. You could use your ingenuity, and if you have any question or if you need help, let me know in the comment section and I'll do my best to help you. First thing I'm going to do, I'm going to take measurement for the cooler. I'm going to take 290s and I'll try to have the cooler between this and this. So center to center, and then I will cut the pipes and I'll build it this way, and this will help cool the compressed air. The reason I want to go center to center, so I could use these over here to be able to bolt them to the wall of this square tubing. All this scrap metal, if I have to buy the metal, I'll build it taller and I will add fan on the top to blow cool air on top of the compressor motor and all this. I may end up doing that anyway, but if you are buying the material, then buy it and build it taller than your compressor. However, if you have scrap metal like me, just use your ingenuity and build it the way you like it, with the material that's available to you. In the past, I used this oil cooler. However, it didn't last more than 3.5 years. The reason for that, inside this tube, they have fins like this. And if you don't do the filter upgrade, then the compressor pump will suck dirt and other debris in the air, and with time it will fill this cooler and it will not be efficient. It will have restriction inside it and it will not allow the air to flow smoothly inside it, and then you end up have to replace it. And this is expensive. If I remember correctly, I paid about $170 for this one. But for this, I'm going to build it out of this copper tube. I believe it will be better because the copper pipe has a copper wall and more surface area, so it will distribute the air. And I'm going to build it over long sections, so even if I don't add fan, the available air around the tank or around the air compressor will be sufficient enough to cool the air before it hit the dryer, and that the dryer will catch any moisture in the air or in the compressed air. However, if you don't want to go through the expense of using copper fitting and copper tubing, you could use something similar to this. You could even use air condition radiator for a truck or a car, but they have same principle. If you use your air compressor a lot, especially if you paint and if you have wood dust, if you do carpentry, etc., and you don't upgrade your filter on your compressor, all this contaminant will get inside it and it will clog it up very quick. After I made about 6 cuts with this, it's got very old, so I went ahead and brought the wood chop saw, and it's actually cut it very smooth and it doesn't leave a lot of burr. And it's way faster than this. And then I could finish it off with this. Once again, this is a wood finish disc. I'll show you how easy it's cut. I like to cut the end of the pipe to clean it. It may have some damage. A 120 grit sandpaper. You need to make sure you sand all the joint before you braze it or solder it. I have these deburring tools. They work great. And then give it one of these. Square and clean cut. Don't waste your time with this. This regulator box is the same height as the saw. I'm using it over here to keep the pipe level. I cut all the long pieces first, and then the pieces that's going to go between these 90s, I cut them last out of the leftover. This way I try to save as much pipe as possible, so not much of it will go to waste. almost finished with the cooler or the radiator for this air compressor build. The way I done it, I welded a U, used two 90s and that splice piece over there, and after I builded all of them, then I connected them on the other side. This way I got them flat. I just need to finish this part over here, and then I will lay the frame on its side and take this, lay it down and connect it to the frame. You need to make sure if you are soldering or brazing to deburr, sand all the fitting and all the pipes. This way you get good weld. The solder or the braze, if you heat the fitting right, it will get inside and it will fill the space between the pipe and the fitting, and you get very strong joint. I elected to go with the brazing. It's more expensive, however it will handle pressure and it's very strong weld and it could handle the heat. You may be alright if you use solder. You just need to make sure you solder it good, and this way you get good weld. It's very important to make sure everything clean and sanded. I will finish this part and then I'll show you how I'm going to install it over there. I brazed this part and wait for it to cool down, then I sanded it. And now I'm going to braze the T. I want to make sure it's vertical, so I will connect this pipe temporary and just gauge it with my eye, and now I have it straight. Right there. I'm going to take it back and put it on the table, and I'm going to braze the pipe that go from here and up, and then I bring it back and bolt it to the frame. Yesterday, before I built this one, I took measurement of using these straps, and I thought to bend this one to the outside and use self-tapping screws on both ends. However, I went to the hardware store and I bought these electrical one-hole straps, and I'm going to use them like this. And I set the measurement yesterday for this to be flat to the outside, so they will work just fine. And I made the space over here for this to fit perfectly. And that's what I'm going to do to attach this to the frame, and I will use these to attach the dryer to the frame, because I could use self-tapping screws on both sides. I'm using this box over here to hold this pipe so it doesn't bend. Once I attach it to the frame, then I remove this box. I started working on the dryer. I already assembled the bottom section and I'm ready to braze it. The pieces up there temporary, just to make sure both of these pipes parallel to each other and flat. This over here temporary piece, I'm not going to use it. This will be connected to the piece that already mounted on the frame. I already bolted the radiator to the frame. I left these pieces 5 feet. I cut one piece of pipe in half. I cleaned both ends. It's actually 10 feet and 1 inch. So I was able to clean both ends and remove them. And I want to braze the bottom section because I don't want to burn the paint on that metal piece. I may have to build a guard once I finish with everything and assemble everything, and it will be something I could remove if I want to work on the compressor pump or the motor or anything on this tank, or if I want to remove the tank. And I probably will mount the fan that blow air to cool everything on the top of that. I have everything assembled. The only thing left, I need to braze all these. I'm going to braze this union, and I'm going to braze a union to a pipe, to a coupling, the one that's going to connect to the tank. And then I will assemble pipe like you, and I could remove that if I ever want to remove the tank. I use these to support the pipe and also to act as thermal coupling between the pipe and the frame to distribute the heat and to help cool the pipe down, and that will cool the air. I braze this pipe and I'll have the valve over here. This will collect all the water. I'm going to build a bracket over here to help support this, so when I open and close this valve, it doesn't put any pressure on the pipes. I'm going to lift this with the tractor and braze all this and build the bracket. And once I get all this finished and this frame up, then I'll record again and show you how to install everything. I cut, drilled, grinded, and painted this 1-inch, 1/4 inch flat stock, and I'm using 2 self-tapping screws on this side and on the other side. I'm using 1-hole strap with bolt and nut to tie all these pipes to this flat stock. So right now the valve is very strong. I don't have to worry about it bending or breaking. And this came out great. Now I'm ready to install the tank. Before I put the tank over here, I'm going to add one of these under the tank. It has a drain, so I could drain it easy. I don't have to reach underneath it. I could just do it from the outside. I'm also going to add a 3/8 to hose fitting over here, so I could connect hoses and I could route these hoses to somewhere where I could drain the water so it doesn't cause rust over here or in the future if I put this in my shop, it doesn't cause a wet spot in my shop. I lifted the tank with the tractor and I'm going to install this valve at the bottom of the tank so I could drain it. I'm going to try to make it point to the front if the thread allow it. Everything is a 1/4 inch NPT. I'm using this female to male 1/4 inch 90. And then the 6 inch galvanized 1/4 inch pipe and 1/4 inch valve to minimize the amount of adapters and all that. For those who don't know how to apply Teflon tape, it's very easy. Just do it in the direction of the thread. This will thread like this, so we need to wrap it with Teflon tape this way. This will minimize the possibility of leak. You tie it like this, apply a little bit of pressure, and you go about 4 to 5 times. Then pull strong on it like this. And now this is ready. You only apply it to the male portion of the thread. So I will apply it over here and over here. And this will connect from this to the valve. I will go get a plier and tie this up. I was lucky, this tie to the front of the tank and this over here clear. So when I bolt this to the frame that I built, there will be about 1.5 inch clearance from the bottom of the tank to this. And I could open it and close it easy. I will bolt the tank and I will bolt the pump and the motor and all that, and then I come back. I think this video is going to be too long, so I try to make it as short as possible. I installed the pump, the motor, the air filter, the switch, and I ran this plastic tube. I protected in a flex. It go all the way over there, and I installed that connector. The input over here, the entrance for the tank, it's about center line with this. So I'm going to install this, then I have to go at offset to hit that union. I want to show you when you braze pipe, the brazing material will seep between the fitting and the pipe, and I don't know if the camera show it, but it's right there at the joint between the fitting and the pipe. It make it all the way through. With this type of brazing, you need to make sure to heat both fitting and pipe till they almost red, and then start apply the silver brazing, and it will go all the way through. I'll put some Teflon, install this, and then I will build this connection point, and I'll come right back. One of the negative things about working outdoors, you are under the mercy of Mother Nature. It's raining right now. I have to wait a little bit until it stops so I could go and finish the air compressor. Hopefully I'll build a shop soon so I don't have to deal with this. I got this connection done. The way I did it, I built this part over here first. I took one of these 1/2 inch NPT to 3/4 pipe connector, and then I brazed piece of 3/4 inch pipe 5 inch long, and I brazed this part of the union. Then I cleaned everything. I put Teflon tape on the thread, and then I tied this to the tank. I tied it all the way. Then I estimated how to build this part, and I brazed this piece of pipe to this part of the union to 45 on the table. Then I brazed all this on the table, and then I cut this to length, and I braze it on the table at this point, and then I assembled everything, and I brazed it over here after I tied everything in place, and came great. Both union, they sit perfectly. It's loose right now. I need to take it and clean it a little bit, clean the joint, and then I will tie it up. After that, I will come. I'm going to build the bracket over here, and I will install the regulator over here with the gauge. It will be out of the way of the motor. And I'm going to use one of these compression fitting, and I will go with the same size pipe, the 3/8 pipe, from here to the regulator, and then I need to build one from here to the switch over here, or the valve, and this will only release the pressure from the compressor to here, so I don't lose the pressure through the radiator or through the dryer. I cleaned this, and I applied little bit oil on the thread and on the joint of these unions, and I'm ready to tie everything up. A 3/8 type L pipe, it's perfect fit for those 1/2 inch compression fitting. I estimated I need about 40 inches of this tube to go from the pump to that valve. I estimated how to bend it. It's going to be like this. This will drop down. And now I'll measure it and cut this to length. And I'll use this piece to connect from the switch to the regulator. I need to cut it right here. Compression fittings, they just have this ring and they will compress the pipe so the pipe will not come off. You have to put the nut first. And then the ring. I got the bracket painted and it's ready to go. I have the regulator completely assembled. I plug this side, install gauge over here, and it has a directional valve. This is the input and this is the output. I have everything installed and wired, and I fill the pump with oil. Let me explain to you the wiring situation for this air compressor. This motor is 220 volt, and I'm going to run this air compressor out of my generator. My generator is capable of producing 110 volt and 220 volt. Usually in this type of generators, you have two separate 110 circuit, and you have a plug for 220, and that's what I have. This only applies to United States wiring. The rest of the world is different. My generator has a female plug that matches this male plug over here. The one that looks different is the ground. The one across from it is the neutral, which in this case is not connected to anything. These two over here, the 220. Inside the generator, there is two coils. When they connected in the middle, that's the neutral, and the two outside point, you get 220, and then if you read between 1 point to the neutral, you get 110 and 110. The rest of the world, they have the 220 circuit, they have a neutral and hot. Here in the United States, only the 110 circuit has a neutral and hot. Usually the white wire is the neutral, and the black wire is the hot, and the green wire is the ground. However, that doesn't apply to this wiring situation over here, because the 2 point that will get 220 from the generator, they both hot, and you get 220 across from them. I hope this makes sense. However, if you're not familiar with electricity, don't attempt to do any wiring. Hire an electrician for your own safety, because you may get shocked or it may even kill you. I will show you close up of everything, and then I will cover everything, and then I will start the generator and plug this to the generator, and hopefully everything works fine. This tab over here is connected to the green wire, and it's the ground, and the two wire to produce 220, they connected to these 2 points. This switch, it has two separate electrical contacts. When there is not enough pressure in the tank, these two switches, they making. When the tank reach full pressure, there is spring loaded switch. It will disconnect these two electrical connection and disconnect electricity from this to the motor. This also has a relief valve to release the pressure that built on the head of the pump, to allow the motor to be able to spin on the next cycle. Once the air drop in the tank, and this switch activate again, so there is no pressure buildup in this area. I built the valve over there, the one that released the pressure, and it only release the pressure in this tube, all the way to the head over here. So I don't lose air pressure anywhere else. And these two contacts, they side by side. So I connected the cable to the top section, and then the motor to the bottom section of this switch. Your switch may be different. Make sure you read the diagram that come with the switch. And then I connected the cable for the motor in these two terminals, and the ground over here. It's hot at this point. I don't hear any leak. I will check all these points with soap and water. The regulator worked just fine. There is no leak. I checked everything. Everything is good. See the water? As you see, the air in the tank right now is dry. It doesn't have any moisture. This radiator over here will cool the air down, and if there is any water or moisture, it will condense and it will become water. And then at this bottom tube, if there is any water heavier than air, so it will collect in this tube. And then all this is redundant. I have 4 valves, so if there is any water escape or moisture escape, it's going to get trapped in this one or in this one. Hopefully there will be no condensation at the last tube, and that would feed the tank. I have another project I need to get busy with. However, I'm going to use this air compressor to paint the dump truck. If you're interested to see more result, watch that video. I have to run this air compressor at several cycles, so it's going to collect water in these traps. In the future, I'm going to build a filter for it if I use it to run plasma cutter. However, I'm done for now, and everything seems to be great. I have no leak. Everything look good. If I need to troubleshoot anything, nothing in the way of anything else, so I could just work at that part. The generator was capable of running it. That's a good thing. I have these 2 outlets. If I need to fill the tires with air, or I just need to blow something up, remove diesel or something, I could use this one. The regulator worked fine, and I could adjust the pressure. And this one over here, you could lock it once you set specific pressure. I have the guard that go here. This one right here. However, I'm not going to use it because I'm planning to add a fan at the top to cool everything down, or help cool everything down. The air filter look great. This adapter that I built look great. If you didn't watch that video, make sure to watch it. This bracket looking good. The frame in general look good. I could use my tractor to lift everything, and everything contained within the frame. It is very important to have one of these safety relief valves installed in case the switch fails, to prevent explosion, and will act as a safe fail device. I have one installed behind the switch on the high pressure side. I finished with this air compressor and I finalized the video about a month ago. However, I decided to try it before I post the video on YouTube until I'm satisfied with this air compressor, and I am. It's actually doing very good job. The cooler and the dryer that I built, it collects most of the moisture. I get water in the first trap, little bit moisture in the second one, and in cold days like today it's below freezing temperature. The last trap and the tank, they don't get any moisture whatsoever. I'm not getting any moisture in the tank, but when I open the valve, sometimes I get just little bit mist. It's been through about 15, maybe more cycles where I fill the tank all the way and empty it, and it's doing very good job. I also added a crossover here, and I have right now a 1/4 inch, 1/2 inch, and a 3/8 quick connector to be able to connect my tools to it. I have tools at different sizes. I will take the camera and I show you a few things I have over here so you get good idea of what's going on. Most of the heat been happening over here on this pipe. As you see, it discolored. However, the temperature drop where you could touch this pipe as the compressor is running. Right now the compressor is full of air. I added this cross, it's 1/2 inch, to be able to connect this 1/4 inch, so I have two of them. One is not regulated and one is regulated. I added this 1/2 inch a quick connector and a 3/8 quick connector. The 1/2 inch, I put it straight because I'm going to drive this 1 inch impact wrench. It's a brand new, I'm going to review it. And I also want to be able to run my air tools. This is 1 inch, a 3/8, and 1/4 inch. I like the Goodyear and the Craftsman product because the rubber is very flexible. Even though today is below freezing, this hose is still flexible. And this is my 1/4 inch setup. And this over here, I bought it brand new. I added the 1/2 inch connectors over here to be able to drive this impact. In the first video of this series, I showed you how I rebuilt the pump. In the second video, I showed you how I built the filter for the air compressor. And in this one, I showed you how I built the frame and the cooler. In the future, I'm going to post a video about adding a fan over here to help cool the pump and the motor, especially in the summer. I'm also going to build a rack to be able to wind this cable and the air hoses on this, so everything will be contained over here. I hope you enjoyed this series. Thank you for watching and thank you for your support, and I'll see you later. Take care.